All right, we're going to get into some application problems having to do with scale factor and how it's related to three-dimensional objects. We introduced 2 questions in the previous lesson, so here's an additional 2 questions. I'll read it to you and give you some guidelines as far as how I think we might want to solve this. So, the Great Pyramid of Giza in Egypt was built on a square base with the dimensions shown. So these are the dimensions shown. An artist who works with plate glass wants to build a replica of the pyramid for an installation at an art gallery using a scale factor of 1 to 60. How much glass will the artist need to build the sculpture? Now, the first thing to understand is ultimately, and you generally want to think about what the full goal is, if it says how much glass will the artist need to build the sculpture, that means that we're dealing with a surface area problem, ultimately. And in saying that, it's good to know the formula because that'll give us a goal in the long run. So what we know about surface area is that the original surface area times the scale factor squared is equal to the new surface area. And if we're to apply that a little bit more, we already know what the scale factor is. So the original surface area times the scale factor squared, which is 1/60th squared, because they'd like to make it smaller, is equal to the new surface area. So the big idea is if we could know the original surface area, which is the surface area of the actual pyramid in Giza, then I can figure out the new surface area because I just take that original surface area and multiply it by 1/60th squared. So the big question would be, what's the original surface area? What we're going to do is assume that we have all 5 surfaces. So even though maybe in Giza they don't have the bottom surface here, they just have the outside triangles, this is the net here, we're going to assume that in order to build the artist to build this sculpture that they need to have all 5 surfaces. So the formula for surface area is length squared plus 2 times length times side length. So first thing we need to do is understand what the L and S represent. The L is the length, so this here is L, and S is the side here. So that's S. So this height here is not to be used. So the surface area of the original is equivalent to 230.4 squared plus 2 times 230.4 times 186.4. If you need justification for that formula, you may want to look at some justifications for the formula for surface area of a pyramid. I'm just using the formula that we were given from the textbook. Okay, so here we go. 230.4 squared is equivalent to that number. Maybe I'll write it down, 53084.16. And 2 times 230.4 times 186.4 is equivalent to 85,893.12. And if I add those together, I have 138,977.28. And that would be meters squared. So now what we have, which is really useful, is we have the original surface area. So we know that this original surface area times the scale factor squared, which we also know, equals the new surface area. So all I need to do is calculate what 138,977.28 times 1/60th squared is. So the first thing I'm going to do is square 1/60th. You have to be careful that you use brackets if you're going to do this in one step. So 1/60th squared, give you a decimal number. In my case it gives me scientific notation, but you should be using your calculator in order to see if you can come up with the same answer. I'm going to multiply it by the original surface area, and there we go. So that should be my new surface area, which is 38.6048 meters squared of glass. And finally, the question says, how much glass do they need to build the sculpture? And that's my answer. That's how many meters squared. All right, the last question in this particular section looks like this. The smaller tank in the photograph has a capacity of 1,400 meters cubed. So the capacity that this holds, or the volume that this holds, is 1,400 meters cubed, and the larger has a capacity of 4,725 meters cubed. During the refining process, both tanks are filled with oil from a pumping station at the same rate. How many times longer will it take to fill the larger tank than it will take to fill the smaller tank? Well, basically what that's saying, if we're filling it up with a volume, it's saying essentially 1,400 times what, because that's how much longer it will take, is equal to 4,725. So there you go. And in order to solve this, what we could do is just divide by 1,400. And we have that the amount of time that it takes longer would be the volume of the larger one divided by the volume of the smaller one, which is 3.375 times longer. Okay? So that's for that particular question. Part B is which scale factor is used when creating the larger tank from the smaller tank. Well, what we know is that to go from the larger tank, the volume, so we know the volumes. So we know, I'm just going to put this here, we know the volume relationship. And I'm going to solve this entire question with this. Because the original question has volumes, we use the volume relationship. We know that original volume times scale factor cubed is equivalent to new volume. Well, if we're going from the smaller to the larger, because we want to know what created the larger from the smaller, we know that the original volume, which is 1,400, times the scale factor cubed is equivalent to the new volume of 4,725. And we actually have the first step of this done, but I might as well prove it to you. So we know that if we divide by 1,400, that the scale factor cubed is equivalent to 3.375. So in final answer, to get the scale factor, we need to take the cubed root. And the scale factor used to create the larger from the smaller, this is a little bit adventurous on your calculator. Lots of you have different buttons in order to take the cubed root. So cubed root, you may have a button that looks like something like this. I have some calculators that have something that looks kind of like this. If you are using or it might be above a button, you might have, this is your x to the y button, and above it you have y cubed x, but there's lots of buttons. On my graphing calculator to take the cubed root, I actually have to go into my math function, but that's something to try out on your own calculator. So here's the cubed root of 3.375, and the scale factor is, as you can see on my calculator, 1.5, and that's the answer, the scale factor used to create the larger from the smaller. If you're in my class and have the study guide, you're going to want to try this formative question and get me to look at it.